Hello class, today we are going to start a new chapter, study of gas laws. In this we are going to study about the behavior of gases, that means how the properties of gases will change under different condition of temperature and pressure. Then we'll learn about laws like Boyle's law, Charles' law, their statement, their equation, and we need to do the numerical based on it. Similarly, what is absolute zero temperature? Then we'll study about gas equation, the combination of Boyle's law and Charles' law. Then numerical based on it. Then after that we'll see in between that the relation between Kelvin and Celsius scale. That means how we can convert Celsius scale of temperature to Kelvin scale and from Kelvin to Celsius. All these things that we are going to see in this chapter. So before we start, we need to know the properties of gases. Some properties of gases. As we know that matter is anything which occupies space and has some mass, and the matter can be divided broadly into three types: solid, liquid and gases. Out of that we have to study about the gases. So in gases, the state of matter, in the gaseous state of matter, the interparticle attraction is weak. That means the molecules or the particles which are present in it, they are far away from each other. Intermolecular space is large, so the interparticle attraction or intermolecular force of attraction is weak because the molecules are far away from each other, and that the particles are completely free to move randomly in the entire available space is known as a gas. Gas occupies the entire space of the container in which it will be kept, and it can take the shape of that container as well. So let us see some behavior and characteristic properties of gases. Gases are composed of molecules that are in constant random motion. So in gases, the molecules are present in a constant motion. That means one molecule will strike with the other one with the other one. So it will mean continuous motion. So kinetic theory helps in explaining the simple relationship that exists between the pressure, volume and the temperature of the gas. So there is a theory which explains the relation between the pressure, volume and temperature of a gas. The kinetic molecular theory explains behavior and characteristics properties of gases. Say for example, composition of gases. Gases are made of very tiny particles called molecules which are moving in all directions. The molecules are negligibly small in size compared to the volume occupied by the gas. So the molecules are small compared to the volume, total volume occupied by a gas. Next, gases have neither a fixed volume nor a fixed shape. That means the gas does not have a fixed volume. That means if you keep in a container of 5 liter, it will take the volume of that 5 liter container. If you keep it in 2 liter, it will take the volume of that 2 liters. And even if you take in the round separate or rectangular separate, it will take the shape of that. So it does not have fixed volume nor a fixed shape. Next is gases exert pressure in all directions. So gaseous particles, as we came to know that they are in constant motion, so the molecules will collide with each other and also with the wall of the container. So when it strikes the wall of the container or due to the collision, the gaseous molecules exert pressure. It has been found that at a given temperature, time and area, the same number of molecules of gas strike against the wall of the container. Thus gases exert the same pressure in all directions. Next is gases are highly compressible. That means we can compress it. Since the interparticle or intermolecular space between the gaseous molecules is large, so on applying a pressure, the molecules can come closer, thus decreasing the volume of the gas. So the gases are highly compressible. Next, gases are highly expansible. That means it will expand also. Gases increase in volume on decrease in pressure and increase in temperature. So gases increase in volume or decrease in pressure. That means pressure and volume, they are the opposite. We can say the opposite relation. That means if you increase one, other will decrease. If you decrease, other will increase. So when pressure on an enclosed gas is reduced, its particles move apart, thus increasing the intermolecular spaces. As a result, the volume of the gas increases. And when an enclosed gas is heated, kinetic energy of molecule increases. Thus, the molecules start moving faster and farther apart from each other, resulting in an increase in the volume of the gas. So, when you increase the temperature as well as when you decrease in pressure, it will result in the expansible of the gas. Gases have very low density. That means the number of molecules per unit volume in a gas is very small as compared to the total volume occupied by it. Next we have got compared to solids and liquids. Next we have got gases have a natural tendency to mix with one another. That is process called diffusion. That means gases have intermolecular spaces very large. So when two gases come in contact with each other, their molecules mix with each other in such a manner that a homogeneous gaseous mixture has formed. So say for example, we know that air is a mixture of so many gases. That means gases can mix with each other. And here there is a term called diffusion has been used. Diffusion is the process when the movement of particles takes place from one place to other, or from higher to lower concentration. Okay. Say for example, if you have got something smelling gas and you just open it in a closed room, so what will happen? After a certain time, you'll find that in every part of the room, within a few seconds, you'll get the smell of that. That process we call as a diffusion. Next is gases can be liquefied. So on cooling, the kinetic energy of the molecule of gas is reduced, and on applying pressure on a cooled gas, the molecules come closer. So when the intermolecular space gets reduced, there is an increase in the number of molecules per unit volume, thus the gas liquefied. So on cooling and on applying pressure, gases can be liquefied. So all these are the properties, or we can say the behavior and characteristic properties of a gases.